How many integers n between 1 and 100 inclusive have the property that n to the power n is a square number? So what we can do is, if we write down, try and write down the numbers, maybe we'll see the pattern. So what you see is, if you had 1 to the power 1, that is 1, and that is a square number. And then if you wrote 2 square, you would get 4, which is a square number. And then if you wrote 3 square, which is not, sorry, 3 square, if you wrote 3 cube, which is 3 square times 3, so that is not a square number, so that doesn't work. So this is a square, 2 square is a square number, 1 to the power 1 is a square number. And then is, if you write 4 to the power 4, we can write this as 4 square, square of 4 square, and that is a square number. 5 square, if I 5 to the power 5 on the other hand, would be 5 square times 5 square times 5, and that is not a square number because we have this 5 left out. And then if you do 6 to the power 6, sorry, not 6 square, 6 to the power 6, you would get 6 cube times 6 cube, and that is 6 cube square, and that is a square number. So you see, we already see a pattern that the even numbers, so all the even numbers can be expressed as a square. You can have, so for example, if you were to pick any even number, I think you could pick like 54, so again, if you had 54 to the power 54, you can write this as 54 to the power 27 squared, because 27 times 2 is 54. That is a square number. It fits the definition. So it goes on. So you can write 98. You can write 100, of course, is a square number, and 100 to the power 100 would be a square number as well, because 100 to the power 100 you can write as 100 to the power 50 and then square of that. So that's a square number. So all these even numbers are square numbers. So if you were to add them, you would get, there are 50 even numbers between 1 and 100. Okay, 1 and 100 inclusive, 100 inclusive, not 1. And 1 is also included. Now, what about these odd numbers? If we now work on the odd numbers a bit more, we come to an interesting thing. You see, 3 square, 4 square, 5 square, 6 we've included, 7 we can't do anything, 7 to the power 7, 8, no, it is already included. Let's look at 9 to the power 9. It's an interesting number. Now this can be written as 3 square to the power 9, or you could write it as 3 to the power 9 whole square. So 9 to the power 9 can be written as a square number. And similarly, you can write what is the next square number between 1 to 100. You have 9 is a square number, then 3 square is 9, 4 square is 16. 16 is included in our even number list. And then you'd have 25. So 25, let us see if we can do the same. So 25 we can write as 25 and then to the power 25, and that is 5 square to the power 25, that is 5 to the power 25 whole square, and that fits the definition of a square number. It's a square. So then 25, then that's 5 square 25, then 6, 7. 7 times 7 is 49. You can again see this in 49 to the power 49, 7 square to the power 49, 7 to the power 49 square. Then 7, 8 is included. 9 times 9 is 81. We can do the same with 81. We can write this as 9 square to the power 81, that is 9 to the power 81 squared. So that's done. Anything else, 9 and then 10 is included. So after 50, you can also have, you will have these another set of numbers. So 1, 2, 3, 4, 5. So there are 5 odd, we can say square numbers. So the total number of integers would be 50 plus 5, and that is 55. So the answer is how many integers? That's 55.